If you don't understand this topic, you can lose easy marks in JAMB Physics. But in the next few minutes, I'll make it very easy. Stay with me. In the next few minutes, I will make electrostatics so easy you can't feel it in JAMB. Electric charges. What is electric charge? Electric charge is produced when electrons are gained or lost. If a body gains electrons, it becomes negative. If a body loses electrons, it becomes positive. Now, let's talk about an atom. I'm going to talk about an atom. Now, what is an atom? An atom is the smallest unit of an element. So every atom has proton. Proton is positive. So that is the sign. Atom has electron. Electron is negative. An atom also has neutron. Neutron has no charge. So it's 0. Normally, number of protons is equal to number of electrons. So the atoms is neutral. That is when no charges are formed. Now let's take a look at how charges are formed. Charges are formed only when electrons move. Electrons moves. So here no protons. No protons. Now when it moves, it gains electron to become negative charge. It loses electron to become positive charge. Now, I'll talk about types of charges. Types of charges. Types of charges. There are only two types. We have positive charge, and negative charge. Now for positive charge, examples are glass rod. It's an example of positive charge. Now glass rod rubbed with zinc. Glass rod rubbed with zinc. This is an example of positive charge. Example of negative charge, we have ebonite rod rubbed with 4. So take note of that. Note, like charges repel, unlike charges attract. Examples of what I mean, we have, now take a look at this sign. This is the negative sign, this is the negative sign. Do you understand? Now when it comes in touch with each other, it's repel. Do you understand? But when positive and negative comes in touch with each other, it attracts. That is what I mean by like charges repel, unlike charges attracts. I'll talk about conductors and insulators. Conductors and insulators. Now, what are conductors? Conductors are materials that produce electricity or that allow the flow of electrons through them. Conductors, they allow electricity, that is electrons, to pass easily. Examples are metals like copper, aluminium. Do you understand? We also have graphite, salt water, human body, earth. These are examples of conductors. I know you may be wondering, human body, is it a conductor? Yes, the human body is a conductor, and I'm going to explain why. The human body is a conductor because it contains water and dissolved salts. These salts produce ions that can move freely, allowing electric current to pass through the body. So if they ask, why can't a conductor hold charge when held? The answer is because charge flows through the body to the earth. Remember I said a conductor is any material that allows charges to move. Do you understand? Now, salt in water is a conductor because it forms ions, and those ions are called Na plus and Cl minus. So the Na plus and Cl minus involves the movement of what these ions, they give electricity flow. Do you understand? So salt water conducts electricity because it contains mobile ions. Do you understand? So take note, salt water is a good conductor, while pure water is a poor conductor. Now for graphite is a form of carbon, but it has free electrons. So 1 electron per atom is free. These electrons can move. That is why it is said to be a conductor. For metals like copper, aluminium, they have free electrons. Electrons move easily through the metal. That is why metals are the best conductors. Examples, we have copper wires. We also have aluminium cables. All these are examples of conductors. We have iron. So metals conducts electricity or contains the flow of what? Of electrons. Do you understand? Or do you still want me to talk about the earth? The earth also contains water and ions, so it allows the flow of electron. So all these are examples of conductors. Now I'll talk about insulators. What are insulators? Insulators, they are materials that do not allow the flow of electrons. They do not allow the flow of electrons or electricity to pass easily. They do not allow electricity to pass easily. Examples, we have plastic, we have rubber. Do you understand? We have rubber, we have glass, we have wood, paper, and zinc. All these are examples of insulators. They are called insulators because they do not allow electricity to pass easily. Now I'll talk about how charges are produced. There are three methods in which charges are produced. The first method is friction. The second method is conduction. And the third method is induction. Induction. Now, before I proceed, I'd like us to go back to this paper. If you were asked in your exam, or you were asked randomly that why is paper an insulator? Why is paper an insulator? Or why is plastic an insulator? What would you say? You would say plastic is an insulator because its electrons are tightly held. So since the electrons are tightly held, they cannot move freely because they are tightly held. So electricity cannot pass through it, even though it can still hold charge on its surface. It holds charge on its surface, but it cannot what? It cannot move freely. Do you understand? Take note of that. Before I talk more about friction, I would like to ask a question. Question is, two materials rubbed together acquire opposite charges. This is charging by. The option is displayed on the screen. What do you think is the answer? The correct option is B, friction. Reason, rubbing is friction. Rubbing is friction. This is exactly how charges are produced. So if you see the word rub, R-U-B, the answer is always friction. No thinking needed. Do you understand? Now you may ask, what is friction, or what's the definition of friction? Friction means rubbing two materials together. Rubbing two materials together so electrons can move. What happens during friction? When two objects are rubbed, electrons move from one to another. So when it moves from one to another, one becomes positive while the other becomes negative. Example, we have comb plus air. This is an example of friction. We also have balloon plus clothes. This is also an example of friction. Now, friction here means rubbing two, this friction here, it means rubbing two materials together so that electrons move from one material to the other. That movement of electron is what produces static electricity. When two different materials are rubbed together, what happens? They touch very closely. Rubbing gives more chance for electrons to move. One material loses electrons, the other material gains electrons. So, after rubbing, the one that loses electrons becomes positively charged. The other one that gains electron becomes negatively charged. Take note of this. What actually moves is not the protons that move. The protons here don't move. The protons don't move. It is mainly the electrons that move. Take note. It is the electrons that move. Now, I'm going to talk about this comb and hair rubbing. Now, what happens when you comb your hair? You can pick up your plastic comb. Let's do this together. What happens when you rub a plastic comb on your dry hair, especially on your dry hair? Electrons move from the hair to the comb. Electrons move from this hair to the comb. Now, the comb gains electrons while the hair loses electrons. So, when the comb gains electrons, the hair loses electrons. What happens? The comb becomes negatively charged while the hair becomes positively charged. This hair becomes positively charged while the comb becomes negatively charged. Do you understand? Now, you may ask, why do we use plastic comb? We use plastic comb because plastic holds extra electrons easily, while dry hair gives up electrons more easily. Do you understand? Now, you observe after combing your hair, if you have, let's say you have paper around you, you understand, like tiny paper around you. If the comb is brought near that neutral paper, the charge, you understand, the charges in the paper rearrange a little. You know why? Because the comb already is charged. So that comb attracts tiny pieces of paper. You understand? The comb is already charged. Remember, the comb is already charged from the air. Do you understand? Now, when it is brought near neutral paper, the charges in the paper rearrange a little. What happens? Opposite charges move closer. Attraction becomes stronger than repulsion. So the paper is pulled towards the comb. The paper is pulled towards the comb. Do you understand? Then for balloon on clothes or hair, when you rub a balloon on clothes or dry hair, the same kind of thing happens. Now, many students make this mistake. Comb and paper is not friction. The friction only happens when you rub the comb on your hair. That is when it happens. That friction only happens when you rub the comb on your hair. But that attraction of the comb and paper is due to induction. In my next video, I'll talk about conduction and induction. Okay, I'm going to talk about this balloon plus clothes. Balloon plus clothes. Remember, I said the same thing that happens here also happen here, but I will explain that. Now, balloon on clothes or hair. When you rub a balloon on clothes or dry hair, the same kind of thing, like I said, happens. What happens? Electrons move onto the balloon. Electrons move onto the balloon. The balloon becomes negatively charged. The clothes or air loses electrons and becomes positively charged. Now afterwards, what do you observe? You notice that the balloon sticks to the wall. You understand? This is where confusion comes in. You understand? Many students get confused here. You understand? Take note, the wall may be neutral. Do you understand? The wall may be neutral, but when the charged balloons comes near it, charges in that wall shifts slightly. Now when it shifts slightly, it creates attraction between the balloon. It creates attraction between the balloon and the wall. So the balloon can still stick for some time. That is why balloon also attracts paper. Do you understand? So paper is neutral. Balloon is charged. The charges in paper rearrange. That is why the paper is what is attracted. Do you understand? Also, the same thing is applicable when you rub balloon with your air. If you bring that charged balloon near your air, I mean this air. When you bring that charged balloon near your air, you notice that the air may remove towards it. Do you know why it removes towards it? Because of electrostatic attraction. Because of electrostatic attraction. You understand? That is why mostly in exams they like making use of dry air instead of wet air. You understand? They prefer dry air to wet air. Dry air works better because water or moisture allows charges to leak away. You understand? So in dry conditions, charges stay longer. That's why the effect is stronger. That is why static electricity is more noticeable in dry weather. Note, the object that gains electrons becomes negative. Take note of this, please. The object that gains electrons becomes negative, while the object that loses electrons becomes positive. Please take note of that. So right now, I'd like to test your understanding so far. So I'm going to give some questions. Quick one. If two bodies are rubbed together and one becomes negatively charged, what actually happens? You have 5 seconds. Think. The answer is B. Gained electrons. Shortcut answer. Negative always means gain of electrons. Take notes. Negative always means gain of electrons. So no stress. Question 2. This one confuses a lot of students. Listen carefully. If a negative rod is brought near a metal fair, what happens to the side close to the rod? Don't rush. Think. Correct answer is B. Positive. Why? Because electrons are pushed away, so that side becomes positive. Question 3. Why can't a conductor hold charge when you touch it? Now I want you to think like an examiner. The correct option is B. Charge flows to your body and then to it. Remember I said your body is a conductor. If you have forgotten why I said your body is a conductor, You can scroll back, start the video again. Question 4. Why does a charged object attract something that is neutral? This is where many students get it wrong. The answer here is C. Electrostatic induction. Take notes. Charges rearrange, not created. Charges rearrange, they are not created. Question 5. Which material stores charge best? Don't guess. Just think about it. Answer is C. Rubber. Remember, insulators store charge. Conductors lose it. Conductors, they lose charge, while insulators store charge. Question 6. What does it really mean for a body to be neutral? Careful, this is a trap question. Answer is B. Equal positive and negative charges. Question 7. During friction, does charge increase, decrease, or stay the same time? Or stay the same? Think physics law. Answer is C. Remains constant according to the law of conservation of charge. Question 8. Which one is true about insulators? Don't mix this up. The answer is C. They restrict electron movements. Question 9. If a plastic rod becomes negative after rubbing, where did the electrons come from? Think direction. Just think about the direction. What do you think is the answer? Answer is B. From wool to rod. Question 10. If a charged comb touches paper, what happens? Yeah, I want you to think about contacts. Yeah, think about the contacts. The answer is B. The paper becomes charged. Question 11. Which of these is not a method of charging? This is easy. The correct answer is D. Convection. Question 12. This question is a trap. Glass becomes positive after rubbing. What happens to zinc? This one is tricky. Answer is A. Zinc gained electrons. Question 13. What truly defines a conductor? Don't overthink it. Answer is C. Free electrons. Question 14. A neutral object is attracted to a charged one. What does that prove? Yeah, I want you to think carefully. The answer is C. Charges rearrange. Question 15. Final one. Can charge be created or destroyed? Think about physics law. The answer is C. Charges are conserved. charges are conserved. Now this is just part 1. Part 2 is where everything becomes clear. I will show you the exact questions JAMB loves. Subscribe now, you will see it first.